Hello, welcome back to the channel. So let's do one more question on identifying when an integral is said to be an improper integral. So we have already covered the concept of improper integrals, the introduction to the improper integrals in the last video. So I will highly suggest you to first watch that video in order to get the full context of this video over here. So in this question, we have to basically identify the values of b for which this definite integral, the integral of 1 upon x square plus 1 dx from x equals 0 to x equals b is improper. So again, we'll use the same concept that we covered in the last video. You know that there are basically two reasons for a definite integral to be an improper integral. The first reason is when one of your endpoints is not a real number. So which means if one of our endpoints, since in this case we are identifying the values of b, in this case, if our b is plus infinity or if our b is minus infinity, this integral over here would be an improper integral, right? This is what we already know from the previous video, which is the first reason about a definite integral being an improper integral, right? And the second reason that we covered in the last video was when the domain of the integration, the interval of x for which we are calculating the integral for, has a discontinuity point, right? But in this case, we can clearly see that the domain of this function is defined for all real numbers, right? Because the denominator cannot be 0 in this case, since it's x square plus 1 and we know that x square is always greater than equal to 0. And since x square is always greater than equal to 0, the denominator is always greater than equal to 1, right? So we can clearly say that the denominator is never 0 in this case. So if the denominator is never 0 in this case, the domain of this function is defined for all real numbers, which means that doesn't matter which real value we take for our b, this function would always be defined at that point, right? So that is why there is only one case for this integral to be an improper integral, which is when our b is either plus infinity or minus infinity in this case. So that was a fairly simple problem to solve only if you know the concepts of identifying a definite integral to be an improper integral. So again, I'll say if you have not watched my previous video, I'll highly suggest you to first watch that video in order to get the context of this video over here, because that video covers more concepts than this video over here. We are basically using the concepts from the previous video in this video over here. So again, feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.